Hello everybody, Mr. B back here. This is the fraction series of videos, video 2. Here we're going to be multiplying fractions and determining equivalent fractions. We're going to learn what an equivalent fraction is and how to find them. So first of all, just mathematically we know that if we want to double something, we multiply by 2, right? So if we want to double something, we multiply by 2. We multiply by 2. I'm not going to do lots of writing. It's going to take too much time. But anyway, if we want to double something, we multiply by 2. So for example, if we have 4 and we want to double that, we multiply by 2 and we get 8. And I'm using a dot for multiplication here, not the little x. Mathematicians don't like the x because then it looks like an x variable or something. But anyway, let's say we want half of something. So if we want half of something, let's say we want half of something, we multiply by, you guessed it, a half. So for example, let's take that 4, multiply by a half, and now what? Well, here's the process. We can write the 4 as a fraction, 4 over 1. So 1 divides into 4 4 times, so 4 over 1 equals 4. We're multiplying by 1/2. And what we do is we multiply the numerators and we multiply the denominators. And you can see that we're going to get 4 over 2. And remember we said the fraction bar was division, so 4 divided by 2 is 2. Half of 4 is 2, just like we expect. So when we multiply something by a fraction, we get that fractional amount of whatever we're multiplying by. So half of 4 is 4 times a half. We get 2. The process here, here's just a general way to think of the process. So if you have a fraction a over b times c over d, where the a, b, c, and d are just some whole numbers, we multiply the numerators and we multiply the denominators. It's that easy. Multiplication is the easiest operation, as they call it, to do on fractions. So, all right. Next question, or the next topic here, are equivalent fractions. Equivalent fractions. So equivalent fractions are just fractions that are equal to each other but have different numerators and denominators. So they're equal fractions with different numerator and denominator. I'll just abbreviate these. Denominator. So here's an easy example to see. How about 1/2 and 2/4? Visually, this is super easy to see with a pi or even a number line. I'll do both. So the first fraction is saying divide up the whole thing into 2 equal pieces, and we want one of them. The other fraction is saying divide up the whole thing into 4 equal pieces and take 2 of them. So I think visually you can see that we're shading half of the circle, right? And if you did it with a number line, here's 1, here's 0, here's a half. If we divide up into fourths, this would be 1/4, this would be 2/4, this would be 3/4, etc. So we see that 2/4 and 1/2 is really the same thing. Okay, so there's actually an infinite number of equivalent fractions for any particular fraction. And just to give you an idea how you could find some more equivalent fractions, it has to do with multiplication by 1. So I'll just say, recall that if we take any number, and we multiply it by 1, we get the same number, right? Doesn't change the number. So for instance, if we have 6 times 1, we get 6. If we take 127 times 1, we get 127. If we take 2/3 and we multiply it by 1, we get 2/3 again. So these are different examples of multiplying by 1. Okay, really easy, right? Basic idea. Okay. We also found out that when the numerator equals the denominator, we get 1. So 1 can be written in an infinite number of ways, right? I'll just put a little infinity sign. So 1 could be 2/2. It could be 3/3. It could be 4/4. It could be -2/2. It could be 1028/1028. Okay, so, etc. I want to show that two-thirds times 1. We already said we said this above, right? 2/3 times 1 is 2/3 still. But we could write 1 as, what did I choose here? I'm going to write it just as 2/2. This thing equals 1 still. And now we multiply the numerators, we get 4. We multiply the denominators. Maybe I should have actually written it that way so that I'm following you can see how I'm following the process we talked about for multiplication. 2/2 times 3/2, and this is 4/6. So basically, we've just said that 2/3 equals 4/6. These are equivalent fractions. They're the same number. You could put them on a number line, right? If this is 1 and this is 0, and we divided it up into thirds, this is 2/3 here. But if we divide it into 6 equal pieces, which it basically split all these pieces in 2, this would be 4/6. 4/6. 1, 2, 3, 4. Again, sorry, these are not all equally divided, but I'm doing it too quickly, I guess, for my own good. Okay. So I said there were an infinite number of equivalent fractions. We can take 2/3 and multiply by 3/3, and then we get 6/9. We could multiply by 4/4, and we'd get what? We get 8/12. Anyway, got the little box there, sorry. So 2/3 is 4/6, it's 6/9. It could be 8/12, etc. There's an infinite number of equivalent fractions. Okay, where are we headed with this? We may want to choose to write a particular fraction with a denominator that we want. So we choose the denominator and we want to know, how do I write this fraction with this new denominator? It's super easy. So let's just say we often want to write a fraction, a given fraction, with a chosen denominator. So here's an example of this. What fraction is equivalent to 2/3 and has a denominator of 24? Some of you probably do this in your head, you're done already. But let's say we're not done. Let's set this up the way we did the other ones. Basically, we want 2/3 times a fraction that equals 1, where the final fraction has got 24 in the denominator. So we don't know what this is, we don't know what this is, and we don't know what this is yet, but they're easy to figure out. Okay, so I'm going to call this, the numbers here I'm going to call A. We're going to find this value of A. I could have used X, but I like A more, at least at the moment. So we know that when we multiply, we have to multiply straight across. We multiply the numerators and the denominators. What's cool, though, is that we see that the product means the multiplication of, that the product of these denominators has to be 24. So we see that 3 times A has to be 24. So what number times 3 gives 24? It's basically 24 divided by 3. You know, that's 8. So 3 times 8 equals 24. So A equals 8. Okay, so now we see that, at least in our little picture here, that we got 2/3 times A over 8 equals the 24. Okay, what's this A have to be? Well, I've written it A over A because it has to be the same thing over the same thing, right? The numerator has to equal the denominator so that we get 1. So it's not A. I can write the numerator as 8. Once we find out that the denominator is 8, then we know that the numerator is 8. Numerator is 8. That one. Therefore, this thing we don't know is easy, right? It's 2 times 8. So 2/3 times the 8 over 8. We get the 24 on the bottom, and the top is going to be 16. So here's our equivalent fraction to 2/3 that has 24 as a denominator. Okay. So 2/3 equals 16/24. Almost looks like 16/29. Let me fix it. 16/24. You could do all this in your head. Here's the way I learned to do this way back when. You write the fraction that you want. See, I'm going to pick 3/5. That's the fraction we're given. And let's say that we want this to be a new fraction, equivalent fraction with 30 as the denominator. Well, we don't even have to think about the other process. It's basically the first thing we do is divide the 30 by 5. Remember how we got A? We got A by dividing the denominator we wanted by our given denominator. So that's really the first step, except we're doing it in our head. So 30 divided by 5 is 6. The second step is you multiply the numerator you have by that 6, and that's 18, and that goes right there. So there it is, done. So you divide 5 into 30, and you multiply the result by 3 to get 18. Simple? Yeah. If this is not so clear, well, just go back and do it this way, where you write, the steps are, I do it this way. I write 2/3, I write a fraction bar, and then I put the 24. And I go, okay, 3 times what gives 24? That was 8. Then I know the top has to be an 8 too, so that I get 1, and then the numerators multiply to be 16. Done. So either way is pretty quick. Okay. This has turned into a sort of long video. I'll just say I won't show an example, but it's possible to choose denominators of the equivalent fraction that the denominator you have doesn't divide into evenly. And then you get a number for the numerator that's not going to be a whole number. You can try it. It works. There's a few applications out there, but not anything that we want to deal with right now. Okay. Equivalent fractions, very, very important and a useful skill. We'll see you in the next video.